First thing we do in this experiment is we draw around our glass block, and we then remove it and mark the center of the flat side. So using a ruler, so it's going to be there, and we could draw normal if we wanted, but it's not overly necessary at this point. The reason we use a semicircular glass block is because if we aim a ray at that center, then there's no refraction going from air to glass here, which means we can increase the angle of incidence inside the glass block more easily. And all we do in this experiment is, at the minute you can see at that angle of incidence, we get refraction, and we just keep increasing the angle of incidence. And you can see that the angle of refraction gets bigger and bigger and bigger until we get to the case where we get an angle of refraction of 90 degrees. But in fact, it's quite hard to get that accurately, and it's quite hard to see it at that point. So what I would do is I would just increase that angle until we get total internal reflection. And if we go 0.0001 of a degree bigger than the critical angle, we get total internal reflection. But if we measure the angle I now, it will essentially be exactly the same angle as the critical angle. And all we do is we mark the two rays, both the reflected and the incident ray. We remove the ray box. We join up these two lines. And we then measure this angle in here with a protractor, which we call theta. And when I measure that, I get that this angle is 84 degrees. But that angle is made up of I and R. So if we divide the theta by 2, it gives us our angle of incidence, which is 42 degrees. And that's our critical angle. Okay? However, this question then asks us to work out the refractive index, and we have that the refractive index from air to glass is 1 over sine c, so we put in our 42 degrees, and that will give us our refractive index. Okay?